Hello everyone and welcome to my YouTube channel. I'm making a tutorial after a long time, and today we are going to build a tiny, I won't call it tiny, but because it has got like hundreds of thousands of documents, and we are going to build a search engine from scratch using BM25 and Vespa. So this is going to be a really basic intro to building your own scalable search engine. And we'll point it at a real web dataset. We are going to use the fine web dataset from Hugging Face. And by the end of the video, you will be able to type simple queries like pineapple pizza and get back real search results ranked by BM25, just like a super simplified version of web search engine. So this is going to look something like this. So you type uh, pineapple pizza as the query, and it searches on your local Vespa application and gives you the search results. And this is going to run on hundreds of thousands of documents. Now, today's video has been divided into few different parts. We define a Vespa application with a simple document schema. We spin it up in Docker from Python, and we load the web data. We feed the web dataset, which is the fine web dataset, and run a BM25 query. So let's get started. So I'm in my favorite editor, and here I have a new folder, and I've created this project using UV. So I have a few things installed, such as datasets and PyVespa. So we will start from imports. So what I'm going to do is I'm going to say from vespa.package import, and I hope this copilot thing is going to make my life simple. So let's see, I can import application package, and then I will need field, schema, index. Do I need it? No. So schema and document, rank profile, and field set, and I will also need function. Okay, so I think that's enough. And I will also import from vespa.deployment, I will import Vespa Docker. So we are going to run everything locally today. And from datasets, import load dataset. So because we will be using a dataset from Hugging Face, and from TQDM, let's see, we can use TQDM. We can use it for saying how long it's taking to feed the data. And if you don't understand everything, you don't have to understand everything right now. So this is going to be a series. We have started like from a very basic thing first. So application package, schema, document, and field. These are the things how we describe our Vespa application. So like what our documents look like, which field we index, how we rank, and so on. Vespa Docker is helping us launch a Vespa application inside our local machine. And you're already pretty familiar with load dataset and TQDM. So now we will start designing our own application package. So let's just call it package, and my package is application package, and then I can give it a name. So I'll just give it name simple search. Let's do it like this. Okay, simple search. And now I have created the application package. I also need to attach a schema to it. So how the documents are going to look like. So schema is sometimes I don't like this auto suggestions. So schema is a list. So you can have multiple schemas. So inside that we have schema. I'll name this schema as doc for documents, and inside it contains document, which is document, and inside we have the fields for each document. So here we have fields, and let's do it like this. Yeah. So now you get the idea like how it should look like. So we have schema, which is a list. You can have multiple schemas, and then for each schema here you have the name, document, and inside the document you have different fields. So here I can say I can create a field, and I'll create a field named ID, which is type string, and we are just indexing the summary here. I'll create another field, text, and which is going to store the text, and the type is string. We're indexing index and summary, and we will add index equal to enable BM25. So now BM25 indexing has been enabled for this text field. And similarly, in our dataset, we also have URL. So we can add URL field name equal to URL. Let's see. Yeah, index summary. And we will also index it. So let me explain you what's happening here. So we have created an application package named Simple Search. So you can think of this as configuration of your search engine. We define one schema called doc, and this is basically the document type we are going to index. Here we have ID, so which is the string field, and we have text. Text is again string, and index summary means index it for search and also store it in the summary so that we can return this field in search results. So that's why here we are not using index because we don't want to search on ID, but we want to search on the text, or we want to search on the URL. Okay, and for text field, we have also enabled BM25 index. Okay, so now here we need to define a field set called default. So we can do it here. Think name. Yeah, okay. So we have the document and then field sets, and this can be field default. Yeah, okay. Name default fields are text and URL. So when we are searching on both the text field and also on the URL field. So like if the URL is something.com, then we can also search for the URL directly, which may not appear in text. Okay, so now we have defined the field set. So this is useful when we say like search in the default fields instead of listing each field explicitly. Now we have to define something called a rank profile. So now here the fun begins. Now you have to define the rank profile. So we'll say rank profiles. You can have multiple rank profile. And here I will define a rank profile named I don't know. It can be called default, or we can just say BM25. You can give any name you want, and this does the first phase ranking. And here I can we can either do like BM25 text, or we can do um, we can create a function. So which can it can again use multiple functions, but we create one function which has which is the name BM25 um, text URL. So it's like um, it can be any name, and here the expression. So here it should be called expression becomes BM25 of text plus BM25 of URL. So now these are internal functions provided by Vespa. But I don't want to give the same weight to BM25 URL, so I can also say 0.1. So I'll give it only like 10% weight. And now this thing we should change this. So let's see, rank profile, we got name, we got functions. I don't know why it's not auto formatting. I don't like this. And here we can have we will say first phase. So my first phase um, ranking is using the function named BM25 text URL, which is basically the expression BM25 of text plus 0.1 into BM25 of URL. And the rank profile is also named BM25, so don't confuse yourself. You can change it to any other name, but this has to say the same, BM25. Okay, so now at this point we have told Vespa that we have documents with ID, with text, and with URL. And when someone searches score documents by BM25 on the text field plus 0.1 times BM25 on the URL field. Okay, so now the next step is to spin up the application. So to spin up the application, you can do Vespa Docker. Okay, Vespa Docker Vespa Docker. That's it. And now here we have Vespa app equal to Vespa Docker dot deploy application package is package. So we created a Vespa Docker instance, and this manages the Vespa instance running in Docker, and deploy takes application package and deploys it. So everything is running locally. So at this point, you have to make sure that your Docker daemon is running. Otherwise, this is going to fail. So yeah, having Docker is also one of the requirements here. So now we can load the data. So load it from Hugging Face, load dataset. We are using Hugging Face fine web dataset. So let me just copy paste that because then it's going to be easier. And this is like hundreds of millions of documents, so you don't have to upload hundreds of millions of documents if you want to just try it. So we are using this configuration which has the smallest amount of data, and streaming equal to true means like we are not going to download everything to the disk. We are going to stream it row by row. I don't think I can download everything by on my disk anyways. So now we do like we create a feed variable, and this is just mapping the data set using a lambda function. So I say x is id, and then it has to be in the format of Vespa, and which is fields. So now I've taken the ID. ID is available in the dataset, and here I will write text is xtext, xurl, and again, since my doc also contains ID, I will write ID is ID. And we're almost there. So now what we can do is we can start feeding these documents inside this Vespa application that we have created. So to feed the documents, you can create, you can use TQDM to monitor the progress, or you can just do it without monitoring the progress. So all you have to do here is app.feed, and this will start the feed. And yeah, and it's not like this. App.feed underscore iterable, and here you have Vespa underscore feed, comma, schema is doc, and max workers if you want to specify max workers, not non-threads, and show progress doesn't exist. So let me just remove that. Yeah, so that's like the simplest way. Um, yeah, and then we can query it. So the first step would be to just feed the documents. But you can also have some callbacks. So I can say like, okay, I'll just copy paste this part. I create a callback, and also have this tracking using TQDM. So here I think I'm missing an import. We can just ignore it. Okay, let's add it from vespa.io import vespa response, and now we can add the callback here. Add the callback, and then close the progress bar. Um, okay, I hope this should work. Let's try it. Simple search, comma. Okay. Yeah, so it's running, doing something. So now it's starting the configuration server and waiting for the application now. So if everything goes well, it should start feeding the data. So the Vespa application has now been deployed, and everything is running locally. I'll make another video in which you can see how we can do the same thing on Vespa Cloud. But for this video, everything is running locally. Yeah, so now you can see it has started feeding the documents. So now we need to wait for some time. So we are doing 200 documents per second, and these are millions of documents. And I don't want to feed it with 100 million documents, but yeah, if you want to do that, you can do that, and it's going to be fast anyways. So the response is going to be fast anyways. So I'll just wait for some time till it has done few 100,000 documents, and then we can do a search query on it and see if it works. Great. So we have more than 150,000 documents. Now I can either stop it, I can let it run, I can open a new terminal, and now we can do the search. So if I have to do the search, I can also use PyVespa to do the search, or I can just use a curl command. So when you started the application has been running on your local host on a certain port, 8080, which is the default one. You can also change that. So if I have to now search for something, uh, I don't know, what should I search for? Uh, Document embedding, let's say. I don't think there's going to be any search results here. We don't have a lot of data. We have like 150,000 documents. So all I have to do is issue this curl command, and we we provide a query as YQL, which is like, let's say, Vespa SQL, and we select star from sources where default contains, and here is your query document embedding. Yeah, so we don't have anything for document embedding. So let's change this, and let's search for a place. Maybe we have something for Chicago. Yeah. So now you can see, like here we are getting many different search results. So what you get is the relevance, the total count, coverage, and here you're getting these results. So the relevance is 0.25, and Chicago luxury bus. So here you can see the text, and you will also get the URL, and you get many results like this. So um, we can also search for multiple terms if you want, and you see like how fast the search result is. Let's see if I get anything for New York pizza. I don't get anything for New York pizza. Maybe just pineapple pizza. Yeah, found something. Yeah, so it found something, and here I'm getting this is the document ID, and relevance is quite low, but yeah, the text that you get is about pizza, and probably there's pineapple written somewhere here. And yeah, you also have the URL and everything, and you can see like more than 150,000 documents. The search is like instant, and yeah, it's really fast even for millions or billions of documents. But yeah, I don't think I have the hard drive space for um, billions of documents. So thank you so much for watching this video. In the next videos in this series, we are going to build on top of this. We are going to add vector search, embeddings. We are going to move into RAG, and we'll combine this with kind of retrieval with an LLM to answer your questions. We are going to see how to re-rank using XGBoost, LightGBM. It's going to be a quite useful series if you want to build your own search or RAG-based applications. You need search to build a good RAG-based application to get good context. And once you have like hundreds of thousands of documents or millions of documents, everything becomes super slow. But with Vespa, everything's going to be super fast. And if you want the code from this video, you can check out the description. And if you're interested in building your own search, RAG end-to-end, stack for RAG, and then hit the subscribe button, like the video, and don't miss the next episode. See you in the next one.